Hey guys, in this video we are going to discuss 3-point forward formula. So I think you understood the previous method. So suppose this is your function f, right? F of x, right? So you approximated the slope of this tangent to this point, to this curve at this point x naught, using, so you approximated the slope of this tangent to the curve at this point using 2 points. That means you use this point as well as this one. So if this is x sub I, you used, I think you remember, you used these 2 points to find an approximation to this tangent to the curve at xi. So we approximated. F prime. We found an approximation to this f prime evaluated at xi using these 2 points. Now we are going to find an approximation to this using 3 points. So using 3 points, one is this xi. So we want to find an approximation to the slope f prime evaluated at xi using 3 points. This one and in front, using another 2 points in front. Earlier we used only 1 point in front, right? Now we use the extra point in addition to this. So let's write that using these points x I plus 2. So that's why you say the 3 point forward. So we pick points in front, forward, right? We pick points in front of this point xi, right? So these are the points in front of xi. So let's assume the function value at these points is f of xi plus 1, and here f of xi plus 2, right? So using these 3 points, we will find an approximation to f prime at xi, right? So let's see how can we do that, right? All right, you know that. So if you have 3 data points, so you know that how to interpolate, how to find the interpolation polynomial which passes through these 3 points. So you can use either Lagrange interpolation method, or you can use Taylor expansion, Taylor polynomial, right? Either one. So I use for here I use Lagrange interpolation polynomial, right? So I will do that using Lagrange interpolation. You can use any method, any interpolation method, but in the exam you will, it is given you are asked to find this approximation using Lagrange, or which one? Lagrange Newtons or or Taylor polynomial, because if these 3 points are distinct, right, these 3 points are distinct, then there is only one polynomial. There is only one polynomial which passes through these 3 points. That's why you can use either one. You get the same polynomial. That's the thing. Right? You can use either Lagrange or Taylor or Newton's interpolation polynomial. So here I use Lagrange interpolation polynomial, right? So let's find the polynomial. So P of x is the Lagrange polynomial. Yep. So of these 3 data points. So what is the Lagrange polynomial? So basically this is the Lagrange interpolation polynomial, and you have to add the error. So error, when you interpolate, when you find the interpolation polynomial, you will get an error. You have to include that one as well, right? So I think you remember this is here you have 3 points, then so this is the Lagrange interpolation polynomial, right? So L naught is the L naught, L1, L2 are the cardinal functions, and here you have to add the error. Right, this is the Lagrange interpolation polynomial, right? F of xi, this cardinal function L naught of x is this. So in on the denominator you have xi minus xi plus 1, xi minus x plus 0. So you write everything x, so xi minus other points, right? Xi minus other points, all linear factors, with these here. So it start off with xi minus other points, right? On the numerator xi minus other points except xi. So this is your cardinal function L1, L0, L1 and L2, right? I hope I remember this. If you not, you go back to Lagrange interpolation and look through these things, right? Alright, so this is the error term, right? So how do you write the error term? All linear factors using these points: x minus xi, x minus x plus 1, x minus x, xi plus 2 divided by factorial 3 times the third derivative of f at epsilon. Epsilon is a point in between xi and xi plus 2. We don't know the location of xi. This is called psi. Yeah, psi. F, third derivative of psi. So, but we know the psi is located in between xi and xi plus 2. Now basically we want to find here look at this here, same thing, but they wrote capital. These are the cardinal functions, right? So first cardinal functions, so this one, second one, third one, right? And if you since you find an approximation to f prime at some say, so here we find an approximation to this one f prime at xi, right? So we need to find the derivatives of these cardinal functions, right? That's why we differentiate this with respect to x. So when you differentiate this with respect to x, we get these things, right? L1 L0 prime is this one, L1 prime is this, L2 prime is this. I recommend you to sit down with a piece of paper and go through this. You have to do this on your own to understand this one. I think this one is very important in exam. So you are asked to find 3-point formula, forward formula, right? Like 3-point. And so you are asked to find an approximation to this f prime at xi using these three points. So I recommend you to do this on your own, right? Otherwise you won't understand. Right here I help you understand how to do this one, right? First find the Lagrange interpolation formula with the error. This is the error, right? And this is the Lagrange polynomial, Lagrange interpolation, right? And this is the error. All the time you have to find with an error, right? So error, when you interpolate using these 3 points, you get an error. So this is the error. So express that polynomial with that error, right? Then so because you are finding an approximation to this f prime, you have to differentiate this one, the Lagrange polynomial, interpolation polynomial. So that's why you are getting L0 prime, L1 prime, L2 prime. Find those things and substitute that point. If you find an approximation to f prime, for instance f prime at xi, then substitute xi here. So substitute xi, x, yeah, x, this is x0, x1, x2. All right, this is xi plus 1, xi plus 2. So first find the derivatives of cardinal functions, right? Differentiate this with respect to x, right? Then substitute the point, right? So this one is an approximation to f of x. So if you want to find the f prime, then you can differentiate this, right? F prime would be, yep, so f prime of x, so approximation, you write with an error, you don't need to put approximation mark, there should be equal sign because you write with an error, right? So this would be f f of xi. Let me write that. Alright, this one f prime is equal to f of xi times the first derivative of this cardinal function and plus f of xi plus 1 times times the derivative of this plus this, and you have to differentiate this one as well with respect to x, right, to find an n. So for our convenience, let's use this step size. This is h and this one also h. So the gap between xi and xi plus 1 is h, and this one also, the gap between xi plus 1 and xi plus 2 is h, right? So this these points are located equally spaced, right? So define your h for this is for our convenience, right? So, or you can use general case, you can consider general case, but in the exam you have to do it in the limited time. So basically you are given you are asked to find a formula for equally spaced 3 points. So this is so you evaluate, you find an approximation to this using 3 points, 3 points in front with this one, right? Using 2 points in front. So this is called the 3-point forward formula, right? So this is a little bit complicated because so there are a lot of numerical calculations. So then you can substitute this if you want to find. So yep, so you have to differentiate this one as well in terms of x, right? So here there are 3 factors you have to consider separately. Definitely you have to use chain rule, right? So I'm lazy to write the derivative of this one because you have to differentiate. Here this is 3 factors, so differentiate this and you have to write the rest of factors and plus differentiate this factor and write the other factors and differentiate this and write the other factors, and right, you have to write this one. This is the error term, error prime. So error, this is the error, take the derivative of that. And if now we know that we want to find an approximation to this f prime evaluated at xi, then you have to plug that xi into this formula, right? So just plug that one into here, and when x equals xi, so plug this number, this value into here, right? So when you plug that one, and you know and you can use this one as well. So the gaps between xi and xi plus 1 is h, and this one also you have h. You can use that, and finally you get this one here. So this one here. All right. We used I think you understand, we used this is your xi and this is your xi plus 1, and this is your xi plus 2 is equal to x naught plus 2h, right? So do you remember? Yep, this is the h, right? So when you plug xi into here, you get, when you plug xi into here, you get something like this. F prime evaluated at xi is equal to 1 over h, and open a bracket, minus 3 halves times f of xi plus 2 times f of xi plus 1 minus 1 half multiplied by f of xi plus 2, and close the bracket, and this is the error term. You can see that. So when you approximate this by using 3 points in front, right, so you get this error. So that means the error is second order is 2, right? So you can, earlier we get we approximated this slope, this tangent, using 2 points. At that time you get first order error. So if you use 3 points in front, right, like this, so the order of the error is 2. So this one is much better than this one, because order of the error is if the h is very small, the order of the error is minimized. You can minimize the error when you when the step size is very small, right? That's the thing. Earlier we get, I think you remember, so when you use these 2 points and these 2 points, this is, yep, when you approximate f prime using these 2 points, you get first order error. But here if you use 3 points in front, here with this one 2 points here in front of this, right? So let's say this is the forward, so here we use 3 points, right, in front, right? Then the error would be order 2. That's the main thing. So this is the approximation to that tangent at this point, the tangent to the curve at this point, right, using 3 points. This is called 3 points of forward approximation. This is the 2 point forward approximation. This is 3 points forward approximation. So error for this one is first order, error for this one is second order. This one is much better than the previous one, because if you choose h is very small, if you choose these points very close to this point, then your error term would be minimized, because this is a bounded value. So if this is a constant value, right, so this one is a constant value, we must we must focus on the h term. The order is 2. We can minimize the error when the step size is very small. That's the basic idea of this, right?